Welcome to our training on configurable and expandable Modbus IoT controllers. I'm Maria Limoni, Sales Manager here at ICP USA. If you have any questions at any time, please training will last about 40 minutes. We'll start with a brief company introduction and then introduce IoT, Internet of Things, IoT applications, go over MQTT, a common protocol in IoT applications. Then we'll go over IoT expandable controllers and show you how to configure them and implement control operations through an easy-to-use web page interface. We'll go over using SNMP, FTP, and CGI commands. We'll also demonstrate how to use email alarms and use FTP for retrieving data logs with IoT controllers. Steveson from our technical support department will later demonstrate how to use IoT controllers and how to incorporate them into SCADA systems. ICP in Taiwan was established in 1993 and is a manufacturer of industrial data acquisition, data communication, control, and wireless equipment. ICP USA was launched in 2001 to support the North and South American markets. We offer ROHS compliant lead-free equipment. We also provide free technical support and provide product selection assistance based on application requirements. IoT, or Internet of Things, is a hot topic in and out of work environments. IoT includes industrial measurement information, smart homes, smart cities, and intelligent transportation systems. As the Internet network is more and more available worldwide, more and more devices are being created that allow sensor data to get passed over the Internet network. ICP USA specializes in automation, data acquisition, and remote monitoring equipment that's connected to sensors and allows for data collection including tank levels, flow rates, pH levels, a valve's open or closed status, and a light's on or off status. We also provide communication, control, and wireless equipment that allow the data to get collected, manipulated, and acted upon as needed from remote locations. IoT refers to the acquisition of the data and the exchange of the data over the Internet. We are helping machine-to-machine systems where computers and controllers get data and implement control based on measurement information. IoT goes beyond M2M communications and allows for automation in many different fields. We also provide equipment that has Internet communication on board, sensors, and control capabilities for IoT applications. The term IoT was coined by British entrepreneur Kevin Ashton in 1999 and referred to a worldwide network of objects connected to RFID systems. IoT technology brings automation to the next level, creating a new way of communication with increased efficiency. For example, IoT applications in home automation allows for lighting and access control, connected home security, energy efficiency, and appliance control through the Internet through intelligent devices. With IoT, you can unlock your front door from your cell phone to let your dog walker inside. You can see them putting on a leash on your animal through a web camera at your home through your cell phone. You can find out through your cell phone what you need to buy from the grocery store from a smart connected refrigerator. The IoT market has been growing really rapidly. It's projected that the industry is going to be $1.9 trillion in size by 2020 and $6.2 trillion by 2025. Currently, there are about 15 billion devices that are connected to the Internet. In 2020, it's expected there will be 50 billion connected devices. The Internet of Things helps improve efficiency by enabling easier communication and shared data over the Internet. It optimizes performance with automation based on sensor data and reduces costs. For example, with traffic light systems, traditional systems were on timed intervals. Often you had to wait a couple minutes even if there were no other vehicles around in sight. With intelligent traffic light systems, they sense when a vehicle is present and that no other vehicles are present, and the traffic light automatically changes accordingly, saving you time. In this big data era, IoT provides more data for analysis, which helps businesses make informed decisions. In energy monitoring applications, our power meters help save energy by monitoring real-time energy consumption, which provides information for avoiding unnecessary energy usage and costs. IoT technology is being used in various applications across commercial, consumer, industrial, and other sectors. Research shows that manufacturing and healthcare are the two industries that are affected most by IoT. Production processes have increased productivity and cost reductions due to automation and process information availability. People are living longer and longer, and with IoT, they will likely live even longer. Some project healthcare devices to be 117 billion for the market by 2020. Some IoT applications where our equipment is being used includes long-distance emergency warning systems. Our Ethernet Modbus TCP-based data acquisition equipment are used with web-based LED displays for freeway safety. They are used to gather road condition information and to control cameras. If they detect smoke in tunnels, the web-based LED displays direct traffic to a safer route, improving traffic safety and reducing traffic jams. Another IoT application where our equipment is being used is in early earthquake warning systems. An early earthquake warning system consists of accelerometers, communication equipment, computers, controllers, and alarms that provide real-time notifications about earthquakes, which have potential for great damage. Our SAR713 seismic switches acquire seismic activity through MEMS accelerometers, which measure the force of acceleration. They have a built-in algorithm which disregards non-earthquake vibrations of a certain magnitude, making it more reliable. It also has digital outputs that are triggered for the emergency shutoff of gas and water valves for protection of property. Our WinPack and ViewPack programmable automation controllers send alarms, retrieve data, control systems, and automate processes. Early earthquake warning systems trigger trains, elevators, and access to vulnerable freeway bridges to stop during big earthquakes. Bridge monitoring is helpful in preventing collapse and saves lives. VW sensors and ET7000 Ethernet Modbus TCP-based remote analog input modules are installed on each pair of bridges. The data from the sensors is collected by a G4500 programmable controller with Ethernet and cellular communication. When the G4500 detects danger, it displays warning on LED displays and sends text messages to proper personnel as needed. ICP-DAS's Y7902 controller, together with a high-speed FRNet I/O modules distributed all over parking facilities, are used in parking area guiding systems that optimize parking lots by providing drivers with directions to available spaces through a series of blinking lights. As the number of vehicles increases year by year, parking is a big issue, especially in dense urban areas. Automated parking systems provide statistical information outside of parking lots and inform users about the adequate number of spaces, saving them time from driving around and around a parking lot or parking garage. Data is also passed from the Y7902 to a control room with a SCADA system that collects information for display out front of the parking lot. MQTT stands for MQ Telemetry Transport. It's an M2M and IoT communication connectivity protocol that is easy to use and is designed for low bandwidth, high latency, or unreliable networks. The MQTT protocol was introduced by Dr. Andy Clark of IBM and Arlen Nipper of Arcom, which is now Eurotech, back in 1999. It is reliable without requiring a lot of bandwidth and resources, so it is great for mobile applications where bandwidth and battery power are important. MQTT includes methods for actions to be performed on resources. It has a connect method, so it will wait for a connection to be established with the server. With the disconnect method, it will wait for the MQTT client to finish its task and for the TCP/IP session to disconnect. With the subscribe method, it will wait for the completion of the subscribe or unsubscribe method. The server will be requested to unsubscribe the client with the unsubscribe method. The publish method returns the application thread after passing a request to the MQTT client. MQTT protocol is used in the conversion of speech into sign language. The system uses MQTT and a microbroker as its messaging infrastructure. Other applications include monitoring lab experiments, river levels, and environmental information remotely. The UA5231 is a data acquisition controller and communication server for IoT industrial Internet of Things applications. The UA5231's built-in OPC UA server and the MQTT client service support a variety of common industrial communication protocols. It's very small in size, has low power consumption, and supports operating temperatures between -13 degrees Fahrenheit and 167 degrees Fahrenheit, which is -25 C to 75 Celsius. It's ideal for a wide variety of applications and environments. It also has a wide variety of communication interfaces including Gigabit Ethernet, USB, RS-232, and RS-485 for connecting to devices. It runs on a Linux operating system. The kernel is 3.2.14. Applying OPC UA integrates I/O with third-party devices. It imports data to SCADA software, database, or decision-making systems for back-end management, and satisfies reliability, interoperability, and security needs of industrial automation systems. The MQTT communication can bridge the system with the Internet of Things to meet current trends of the smart Internet. The WISE5231 IoT controller is simple to use and integrates easily with I/O modules and sensors on the field side, supports various IoT protocols, and integrates easily with SCADA, MIS, MES, IT, and network management systems for real-time transfer of I/O information. It offers reliable, real-time I/O logic control and data logger functions. It also has a friendly user interface over a website and allows for if-then-else type control logic programming on controllers. It eliminates the need for hard code programming. WISE5231 is connected to different devices as well as sensors, as it can hold an expansion I/O board inside, ranging from a host PC, remote I/O, sensors, power meters, touchscreen controllers, mobile phones, mobile devices, and any device on the internet. With great connectivity, the WISE5231 IoT controller offers flexible solutions. The WISE5800 type IoT controllers provide a friendly user interface for editing logic control through a web page. To edit the logic control, you can use a web browser. No extra software is needed. You can use drag and drop type menus to implement if-then-else type logic. Then you can upload the rules to your controller and you don't have to write any code. The if-then-else logic rule engine allows you to set the logic rules. After you make the rules, the controller will implement them accordingly. With CGI operations, you can send actions to be added to the logic addition as part of logic control in response to specific events. The CGI commands receiving function enables WISE to receive the CGI commands from other network devices. The content of CGI commands received can be in if-then-else type statements to trigger them. For example, anytime a door is opened, you can use the CGI command to make a camera capture the person who opened the door's image. You can also use timer and schedule functions, so you can implement actions based on a specific date or time. For example, these are being used for turning lights on and off, also for triggering alarm bells in schools. With the micro SD card, you can log data right on board. You can also get the data logs through FTP. Now I'm going to pass the presentation over to Steve, who's going to be showing you how to use the controller, and he'll also show you how to use these with SCADA software.
Today I will show you one of our WISE data acquisition controller and the if then else logic rules. After that, I will show you the SCADA, how to pull data from the WISE 5800. I'll be using this data acquisition controller. All the WISE module is capable to send email alarms based on the configurable condition and allow user to implement if then else type control logic. WISE series is designed to be simple, easy to use, and no programming required for system development. Right now, I will show you how to connect and configure the module. So once you open the MiniOS 7 utility, you will search the module, and then it should come up here. And then you can set the IP address. Right now, I'm setting to the local IP address as my network. And then after you set, you can open the Internet Explorer. Just enter the IP address into the URL address bar. Next, the WISE web configuration site will show up here now. All configuration is done by the web server. Let's enter the password. The default password is WISE. After logging in, there should be a different settings, like the basic settings. Let's wait for a moment. Okay. You can see that there's basic settings that can change the name of the module, time, communication. Right now, I'm connected the WISE 5800 with one of i7000 module, which is an i7018 data acquisition module. It has thermocouples input, voltage, and current input. So I set the address to 2 and save. Okay. And on the advanced settings will be the page we are going to set up the email address in internal register, data logger settings, and active I/O. On the rule settings, you can set the rule to send email. For example, I can set if the register 1 is equal to 1, I can then send the email out. Let's do one of these. See. Okay. So after you set up the email, you can actually, there's one more option for you to send the email out. When the connection status, internal register, or the i7000, you can set to 1, then send the email out. I can also monitor the channel status from the channel status page here. Like I can see all the I/O from the i7018 or the internal register. Here, you can change it. Okay. The WISE 5800 is really similar to the WISE 5231, but WISE 5231 has the MQTT protocol built in on the module. It's more compatible with like the IoT controller. Okay, now I will show you how to use SCADA software in this soft to pull the data from the WISE 5800 and the i7000 modules. So now I created a new project. I can insert a new screen here, and I put a screen 2 here. And then on tag, you need to create a project tag. Let's say I want to pull a data from the register 1, register 2 and register 3 from the module. After that, you need to go to COM and add a driver. I add a driver Modbus TCP already. After you add the driver, you should be able to see the main driver sheet here. Let's put in the tag. And the station will be the IP address for the WISE 5800 module, which is 21.127.198.230. The port is 502, address is 1. All should be the same. And the IO address, actually you can look at the Modbus register address table from the user menu. This is the user menu for the WISE module. And then you can see that from 0 to 19, it will be the system data. 20 to 39 is the XW port, which is the expansion. Okay, expansion port data, etc., etc. You can also pull the data from the i7000 modules. Okay, let's get back to here. So I will use the register 1 for 4000 and 1 for X2, for X3, and then make sure you save before you run the program. And then now I'll put some text here. For register 1, and copy and paste, register 3, 2, and register 3. Once you create the text, you need to go to the data link and then select the tag. Okay. Select the register 2 tag. Rack 3. Save it. I can use the SPI to monitor the value here. It's 21. Let's see. Register 2, 128, and register 3, 198. I use a software called Modbus Master 2 to check the register. First I connect it to the IP address of my WISE module, 21.127.198.230. Now I'm connected. I go to the definition, but the address is 1. Okay, and then I can actually see what is the value on register 1, 2, and 3. So it match. When I run it, that's it. Okay. If I run the individual project, I can see the number here. Let's use the Modbus Master 2 to change one of the value. Let's say 130. You can see it change in the individual project also. So we know it's working perfect now. This is how you pull the data from the WISE 5800 or WISE 5231 in SCADA. And then you can also put some other function here, text, checkbox, some graphic can be pulled here. You can see the trend of the data by inputting a trend. Alarm, this is the alarm. You can set the condition to trigger the alarm. Let's talk about the WISE5231. So this is the architecture for the WISE5800. So right now I'm connecting to an analog I/O module and monitor the status in the SCADA system. But WISE5231 has one of the important protocols. It's called MQTT. You can actually remotely control and monitor the status from many perspectives, like the smartphone and the security and surveillance, industrial and automation. Okay. So this is one of the main features for the 58231, and which is full IoT compatible. Anyone have any questions?
Let's see. If you have any questions, just type them into the chat box. So far, there's no questions. Okay, if there's no questions, thank you for attending our webinar. If you have any questions in the future, please feel free to contact us by phone, email, or even our web chat. Thank you again for attending and hope you have a great weekend.